Hello students, welcome to Educate. In the last class, we have discussed about glucose. Now, we will discuss about fructose and the other carbohydrates. Fructose, as you know already, that it is the enantiomers of glucose. And since it's the enantiomers, so it will be also composed of 6 carbon atom. Difference here is that the glucose is an aldose. That is, in glucose, there is an aldehydic group, while the fructose is a ketose. That is, in glucose, there will be ketonic group. Glucose is a hexose, like that. The fructose is also a hexose. And already that in glucose, there will be aldehydic group, while in case of ketone, there will be ketonic group. And that's why the optical activity will be different. Okay, that is glucose is dextrorotatory, while the fructose is levorotatory. But the configuration of the glucose as well as fructose will be also D. That is at the second last carbon atom, that is fifth carbon atom. The OH group will be towards right hand side. Okay, remaining structure will be same, only difference will be that in glucose there will be a aldehydic group, while in ketose there will be a ketonic group at the second carbon. Okay, so let's see the structure of fructose. So same here, glucose here. First one is thus we will have to draw the stick form structure of fructose. So 6 carbon here. Now there is here, there will be a double ketonic group at the second carbon atom, and you know at the third carbon atom there is OH group at the left hand side, and in the remaining one the OH group will be towards right hand side. It will be fructose is what here, that is fructose is, it is also of two types, that is alpha form and beta. So that is alpha and beta, that is that will we will indicate in the cyclic form, and here it will be, it is D and here minus fructose. Only difference is that fructose is levorotatory, so that's why it has been indicated by the minus sign. It is the stick form structure. Okay, now how to draw the cyclic structure? The hydrogen of this one, second last carbon atom, that will get bonded to this acylic, this oxygen. So hydrogen will get bound to this. Now here the valency of oxygen will become destabilized. When hydrogen will go to this oxygen, then valency of this oxygen become destabilized, and here when this become OH, then valency of carbon atom also become destabilized. So this oxygen will get bonded to this carbon. This oxygen will get bonded to this carbon. As a result, there will be a formation of a ring, and ring will be composed of what? So 1, 2, 3, 4. This 4 carbon and this oxygen. So the ring of fructose will be composed of 4 carbon and 1 oxygen. So let's see how to draw the structure of cyclic structure. So I am here doing this one. Now how to draw the structure? So ring will be here, oxygen here, and this one. This is first carbon, second carbon, third carbon, fourth carbon and fifth carbon atom here. Okay, fifth carbon here. So in first carbon atom, when you have draw the structure, again, okay, again I am drawing the structure. This one here. So now this is here oxygen, oxygen here, this oxygen. So this is CH2OH. So CH2OH here, draw the structure CH2OH. So with to this oxygen, one there is first carbon, there is CH2OH here. Sorry, this CH2OH and this CH2OH here. Then this oxygen, this side here. So this side oxygen here, first, second. Let's see, CH2OH. Then after is here OH and first, second, third. At third carbon atom, OH is towards left hand side. So that's why OH will be above. And hydrogen and remaining here OH below. This is the structure of, it is furanose. Its structure is resembles with that of furan. So that's why furan structure here, that is oxygen will be there and same this carbon atom, here double bond, here double bond. It is furan. A structure has been drawn here also. Furan it is. So its structure resembles with that of furan. That is 1, 2, 3, 4. In furan there is 1 oxygen and 4 carbon. Same here in fructose also. There is 1 oxygen and 4 carbon. Okay. So this is the structure of. So this is here. Now how to predict? It is alpha or beta. Alpha or beta. So you already know when OH will be below side, then that will be called alpha. Alpha here, and fructose is levodotative, so minus. And here it's D because OH is was towards left hand side, and fructose. So alpha minus D fructose, it is the structure of alpha D minus fructose, or alpha minus D fructose, whatever you would like, or alpha D, whatever you would like, that is here. That is the structure of fructose here. Clear guys? Very easy to draw here because this one here, this is first carbon, second carbon, third, fourth, fifth and sixth. This one oxygen, this oxygen here, this oxygen. Okay, so here, but guys keep in the mind OH will have to write above or below. Alpha D fructose is like that. You can also draw the beta D fructose. Okay, maybe someone get feel difficulty. So I am drawing about the beta D fructose. Beta D glucose I have not drawn, but I am drawing the beta D fructose. So here simply at this place there will be difference. At this place there will be difference. So here OH is below than alpha, so OH will be above than beta. And here first carbon, second carbon, third carbon. At third carbon OH was left towards left, so OH will be above and hydrogen. And then after this is okay, this one. Clear guys? Now let's see other factors. That was about the structure of fructose. Now then after is disaccharide. Disaccharide. And in disaccharide, first of all you will have to study about the sucrose and then after about the maltose. So firstly let's see about the sucrose. Sucrose is, I have already told that in the sucrose is composed of alpha D glucose and beta D fructose. here is something complication here, then after there will be no complication. Okay, that is because glucose is composed of alpha D glucose and beta D fructose. So let's see how to draw that. So firstly, draw alpha D glucose. So alpha D glucose like that. Measure guys carefully here that it is first carbon, here second carbon, here third carbon. So at third carbon atom only OH is towards above side. Now beta D fructose. So beta D fructose structure. Then after you will have to establish the equation. So alpha D glucose, there is 1,2 glycosidic bonding. There is 1,2 oh, beta D glucose about that. So OH will be above. Okay, OH will be above. This is beta D glucose. OH below, then alpha. OH above, then beta. Now there is 1,2 glycosidic bonding between alpha D glucose and beta D fructose. A number of time in the 12th board examination as well as in NEET examination, question has been asked that in case of carbohydrate, the monosaccharides are bonded through which bonding? Number 1 glycosidic bonding, number 2 peptide bonding, and so on. So in disaccharide as well as in polysaccharide, the glucose molecules glucose molecules or any other monosaccharides are bonded with each other through glycosidic bonding. Keep in the mind, in carbohydrate, the monosaccharides are bonded with each other. That is in case of polysaccharide or oligosaccharide. In oligosaccharide or the polysaccharide, the monosaccharides are bonded with each other through glycosidic bonding. And in case of protein, the amino acids are bonded with each other through peptide bonding. Keep in the mind. MCQ questions a number of time has been asked in NEET examination. In main examination these days has not been asked. I have not seen these days in the recent years that has been not asked. But when AIEEE was holding, that time that questions were asking. So let's see now how to do reactions between 1 to, so here it is first carbon, it is second carbon. So how to react with first carbon and second carbon? 1,2 glycosidic bonding. So you will have to reverse this molecule. You will have to rotate the molecule through 180 degree. 180 degree. Previously, in the compounds, when we were doing the reactions, then there you rotate left side or right side, any side, that will have no any significance. But as it is optically active compound, so it will have the significance. So you will have to follow a rule. When you rotate the molecule, then which is below one, that will go above, and which is above, that will come below. Which is below, that will go above, and which is above, that will come below. So what's the structure here? Then after, again draw the structure of glucose here. So this come here. So CH2OH will go above and OH will come below. And here CH2OH will go above and hydrogen will, oh sorry, above. So it will come below. CH2OH is above, so it will come below. So here CH2OH will come below. And hydrogen will go above this side. Remaining same here. The remaining position same. So there will be here OH, H. Okay guys, then after the hydrogen of this fructose will combine with this OH of glucose, or the hydrogen of glucose will combine with OH of fructose. During this reaction, the hydrogen of glucose will combine with the OH of fructose, or the hydrogen of fructose will combine with OH of glucose, and there will be formation of water. So dehydration, when there will be dehydration of glucose and fructose, there will be formation of sucrose. And that's why when you have hydrated the sucrose, there was formation of glucose and fructose. Sorry. So what's the structure here? So here fructose will get bonded through this oxygen. When this OH and hydrogen get removed from there, then this carbon and this carbon will be bonded through this oxygen. So between glucose and fructose, there will be oxygen here, and then after here. Draw the structure here. The remaining portions will be as it is. So it is now here same CH2OH. Remaining portions you will have to draw like by yourself. Very easy it is. CH2OH here, and then after first carbon here. This bonding that is called glycosidic bonding. This bonding, that is the bonding of this oxygen. This oxygen is bonding this glucose molecule and this fructose molecule. So this is called glycosidic bonding. This is glycosidic bond. Okay guys, clear? This one here, that was about the sucrose. Sucrose, which is also called kitchen sugar, and its use. Have I to tell the use of sucrose? Now let's see about the maltose. And from where the sucrose obtained, do you know? Don't you know? They are written here a number of comments, so you already know. That's why I am leaving that. One thing here. Sucrose is dextrorotatory compound. Sucrose is dextrorotatory compound, and when hydrolysis you will do of the sucrose, then there will be formation of glucose and fructose, of which you already know that glucose is dextrorotatory and fructose is levorotatory. So, and here fructose rotates the plane polarized light through 92.4 degrees and glucose through 52.5 degrees. glucose rotate the plane polarized light through 52.5 degree and the fructose rotate through 92.4 degree. So firstly bend towards left and then after right. So plane polarized light will rotate towards left side more extently. Here what? 52.5 degree, here 52.5 degree, and minus here 92.4 degree. So remaining, that means resultant rotation will be towards left. So sucrose was dextrorotatory, but when hydrolysis was done, then when sucrose is actually the dextrorotatory compound, and when hydrolysis of sucrose will perform, the resultant solution will be levorotatory. So here inversion takes place, and that's why this phenomena is called inversion of sugar. Okay, inversion of sugar, because sucrose is dextrorotatory, and when hydrolysis of sucrose will be performed, then there will be formation of glucose and fructose. Since fructose rotate the plane polarized light towards left more extently than that of the glucose, that's why the resulting solution will be levorotatory, and this phenomena is called inversion of sugar. Okay, question has been asked in 12th board examination, write about inversion of sugar. And in NEET examination, not in the IIT main, but in NEET examination, question may ask about the angle of rotation by the glucose and that of the fructose. So in glucose, the angle of rotation is 52.5 degree, and in fructose it is 92.4 degree. So keep in the mind here this one, who is preparing for the NEET examination and who will appear in the CUT examination, they should also keep this information in their memory. For IIT main, there is a less probability of asking the question, but I am not telling that this question will not ask. May ask, but there is less probability of asking this question in the IIT main examination. In 12th board examination, question about the angle, that will also not ask. And here about that, I am telling that 99.9% chances is that in the 12th board examination, question will not ask what is the angle of rotation of glucose and that of the fructose. But question, there is high chances of asking the question, write about the inversion of configuration. In any language may change, but about the inversion of configuration, the question may ask. Okay, now let's see. Then after is next disaccharide, that is maltose. Maltose is also a disaccharide here, and it is composed of 2-alpha-D glucose. 2-alpha-D glucose will combine there, and that will be formation of maltose. So okay, maybe a number of guys will not feel comfortable to draw this structure, may feel difficulty. So again, I am performing the reaction, how it is taking place. Same as you have prepared the sucrose and the structure in maltose, that is easier than that of sucrose. And what is here maltose? It obtained from barley, which is called malt. In Latin word, the barley is called malt, and that's why the sugar found in the malt, that is called maltose. It is a disaccharide of glucose, alpha-D glucose, and in maltose, the alpha-D glucose are bonded with each other through 1,4-glycosidic bonding. Keep in the mind, in sucrose, the alpha-D glucose and the beta-D fructose are bonded with each other through 1,2-glycosidic bonding, while in case of maltose, the alpha-D glucose are bonded with each other through 1,4-glycosidic bonding. And very easily you can perform here. Let's see. Glucose structure here. This is alpha D plus glucose. This is first carbon, second carbon, third carbon, and fourth carbon. So 1,4-glycine burning. So first carbon of this glucose, it is also alpha D plus glucose. So here the first carbon atom here and second carbon atom here. Oh, sorry, fourth carbon atom here. So hydrogen of this glucose will combine with this OH and form H2O. So H2O release. Now this carbon and this carbon will be bonded together through this oxygen. So very simple, and that will be the glycosidic bonding. So let's see here structure. There will be this one glycosidic bonding, and here glucose, another one. And remaining you can fill up by yourself also. So it is here CH2OH, hydrogen. If in the examination, if you will do during the drawing the structure, if you think that it's I am doing the wrong or not, so then we can keep in the mind that at third carbon atom. So it is here first, second, third. The OH will be towards that is here first, second, third. Here, so it is CH2OH and here hydrogen. So third carbon atom, the OH will be at above, and then after the remaining portions, the OH will be at below. So it is okay. So it is maltose. Not easy. Okay, I hope you will enjoy when you will draw this structure. So you enjoy that, and you will get the payment of that enjoyment in your examination. So enjoy of drawing the structure of these compounds. Now let's see. Now lactose. In lactose, that is also called milk sugar, because that's obtained in the milk. Lactose, that's obtained in the milk. That's why lactose is also called milk sugar. And now let's see structure here. So it is also a disaccharide, and it is the here in this one the beta D galactose and beta D glucose are bonded with each other through 1,4-glycosidic bonding. So lactose is the disaccharide of beta D galactose and beta D glucose. Very easy structure, as you have drawn the two disaccharide. Like that, you can also draw here. So beta D galactose, firstly you will have to draw beta D galactose. So what's the structure? Beta D galactose, that has the structure, cyclic structure will be seen. There will be bigger difference. That is, let's see. Alpha or beta, you know, alpha if OH below at the first carbon atom. If OH will be below, then alpha, and if OH will be above, then that will be called beta. So here OH above, because you will have to draw, it is a structure of beta D galactose. This is structure here. So first, second, and third. This third carbon atom, OH will be above. Oh, sorry, here I have done the mistake. Beta D galactose, structure of the glucose and galactose are similar. So it is like that. Alpha, so OH below, and oh, sorry, beta, so OH will be above, and OH will be above. If it is beta, so that's why OH will be above, hydrogen below. The difference in glucose and galactose is that at this carbon atom, that is first, second, third, fourth, at fourth carbon atom, OH, in case of glucose, OH is below and hydrogen above. In case of glucose, the structure at this third carbon atom, 1, 2, 3, 4, sorry, fourth carbon atom is above, is below. But in case of galactose, the OH will be above. So that's the only difference. So meager difference there is between alpha galactose and that is beta D galactose and beta D glucose. So it is beta D galactose. Okay. Now beta D glucose draw a structure. So beta D glucose like that. It is beta here. So at first carbon atom, OH will be above and hydrogen below. Alpha and beta, that's only predict that at the first carbon atom, OH is above or below. Here OH is in beta, D glucose. So OH will be above. And in case of alpha glucose, so at the first carbon atom, OH will be below. So here OH will be here, beta, so OH will be above. Now the alpha, it is beta D glucose. What happened in here in case of lactose, the beta D galactose and beta D glucose are bonded with each other through 1,4 glycosidic bonding. So here this is first carbon atom, second, third, and fourth. So here the hydrogen of this galactose will combine with hydrogen of glucose, or hydrogen of glucose will combine with OH of galactose. So that's why there will be removal of water. So what happened? This carbon and this carbon will be bonded with each other through this oxygen. That means first carbon atom of galactose will be bonded with the fourth carbon of glucose through this oxygen. And that bonding will be called glycosidic bonding. So that is here structure. So here oxygen, this side here, that is bonded, and to this one. Here hydrogen, here hydrogen. Now store the structure remaining fulfilled. I am again telling OH above because it's the beta glucose. Here, same structure. Here, difference is that OH above, then galactose, and OH below, then glucose. So OH above, hydrogen. Remaining structure, same. This bonding is glycosidic bonding. So it is 1,4 glycosidic bonding. Okay, guys. So here I am writing about that. What is that means disaccharide about this structure. You should write also. What is that in case of sucrose? Sucrose, that is, it is the dimer of alpha D glucose and beta D fructose. And which type of bonding? That is 1,2 glycosidic bonding. That is about sucrose. About the glycosidic bonding, I am writing you just a chart which is in the summarized form. Because in the examination, if you will forget that what was alpha, the disaccharide of which two monosaccharide, and what's the glycosidic bonding, so then you will feel so much difficulty. So that's why I am writing here in the form of chart. You should also write that, and during the examination, when only 1 day is left, so this chart will be quite helpful for you for the preparation. So this one about the sucrose. Second one was about the maltose. So in maltose, that is alpha D glucose and also alpha D glucose, and which bonding 1,4 glycosidic bonding. Lactose, about that, what is that here in the case of lactose? That is beta D galactose and beta D glucose. And which bonding? 1,4 glycosidic bonding. Okay, guys, very easy. Now proceed. So that was about this disaccharide. Now let's discuss about the polysaccharide. In polysaccharide, you will have to study about the starch, the glycogen, and the cellulose. Starch, glycogen, and the cellulose. So in a starch, yeah, so which type of how the bonding is taking place, you already know. So I shall not draw it again, because that will be the time consuming, and when you have already studied this one, and I think you have already become master of drawing the structure of these compounds. So you will also feel that's the wastage of time. So I am telling here directly. Let's see here. So a starch here is a starch that is in the plants. You know, have studied in the junior classes. In which classes I don't know. Maybe 6th, 7th, 8th starch about that. So in case of plants, the food stored in the plant in the form of starch. In the plants, the food stored in the form of starch, and here starch is composed of two portions, that is amylose and the amylopectin. Amylose and the amylopectin. The difference is that between amylose and amylopectin is that in amylose there will be polymerization of alpha D glucose, and each unit will be bonded with each other through 1,4-glycosidic bonding in amylose. And in case of amylopectin, there will be polymerization in which the adjacent glucose molecules will be bonded with each other through 1,4-glycosidic bonding here also. But there will be branching at some places. So when there will be branching, so the 6th carbon atom and the 1st carbon atom, in this branch, the first glucose unit will be bonded with the parent chain through 1,6-glycosidic bonding, and then after only 1,4-glycosidic bonding. So that's the difference. In amylose there is no branching, but in amylopectin there will be branching, and in amylopectin also each glucose units here will be bonded with each other through 1,4-glycosidic bonding, except the first glucose unit of the branch and the main branch to which that is bonded, and the first glucose unit of the branch will be bonded to the main branch, to the main chain through 1,6-glycosidic bonding. Okay guys, so that was amylose and amylopectin. Okay, that is starch is made up of amylose and amylopectin, and in amylose there is simply branching. In there will be simply chain formation, and in amylopectin there will be branching also, in which in the main chain each glucose unit will be bonded with each other through 1,4-glycosidic bonding, and of the branch also each glucose unit will be bonded with each other through 1,4-glycosidic bonding, while the first glucose unit of the branch will be bonded to the main chain through 1,6-glycosidic bonding. Okay guys, now let's see. So what happened here in a starch? I have also told that ripened fruits become sweet because in the unripe fruits there is a starch, and when hydrolysis takes place of that starch, there will be formation of glucose, and finally there will be fructose also. Okay, so that is fructose here formation, and that's why hydrolysis takes place there, and that's why the resulting solutions become sweet. Now cellulose here. So in cellulose is the polymer of beta D glucose. So draw the structure that you also do the work, that draw the structure of beta D glucose and bond them with each other through 1,4-glycosidic bonding. So in cellulose, the cellulose is the polymer of beta D glucose, in which they are bonded with each other through 1,4-glycosidic bonding. Okay guys, now let's see. Glycogen also. Glycogen is called animal starch. Why animal starch? Because the structure of glycogen are similar to that of amylopectin, and that's why glycogen is also called animal starch. Okay, and this one is animal starch, that is called. And where it is stored? It is stored in liver, and it stores in liver and in muscle mainly. Okay, so what happened here? That's in the form of glycogen. The starch stores in the liver. What happened when you consumed the foods and there is formation of glucose? Then after there will be formation. That means these this glucose will combine together and will form. This glucose will combine together and will form glycogen. Oh, sorry. Yes, glycogen. And they will store in the liver. And if you have the scarcity of the glucose, or you need the energy, but right now you have not taken the glucose or any that means fruits or like that. So what happened, that the glycogen dissociates and glucose form, and that glucose provide you the energy. Okay, that was. Next one is importance of carbohydrates. What is the importance of carbohydrates? So carbohydrates, that is here the monosaccharides, that is glucose and fructose. They act as a quick source of energy. I think you have realized that if you felt tired, then after consuming the lime water, that means of the sugar, not of only water with the salt. That's when if you consume the lime water, or that means sugar solution, or if you have consumed, if you will consume the glucose, or if you will take fruit, then immediately you will get energy. I hope a number of guys have felt this experience, that when they consume the fruits, they feel energetic. Why? Because the monosaccharides are quick source of energy. Why I told about the sucrose? Because sucrose, when you dissolve, that means when you make the sarbat, that time, when you make the sarbat, that time the sucrose dissociate into glucose and the fructose, which provide you the energy. Okay. Then after, there is also a number of compounds like sugar. There will be ribose sugar, deoxyribose sugar. They will be the component of nucleic acids. So there will be a structural importance of that also. Cellulose, about that you know already. The plant cell wall is made up of cellulose. That was. Now let's see about the question. Why glucose and fructose are soluble in water? Because they can do hydrogen bond formation with water molecule. But cyclohexane will be not soluble in water because they cannot do hydrogen bonding with the water molecule. Expected product of hydrolysis of lactose. What you have seen, that lactose is made up of beta D galactose and the beta D glucose. So when you will hydrolyze the lactose, then there you will get beta D galactose and the beta D glucose. Next one. About that we have already discussed that not react with Schiff's base glucose, don't react with Schiff's base or NaHSO3, sodium hydrogen sulfide. With Schiff's base or with sodium hydrogen sulfide, glucose don't react. So it indicates that there is no aldehyde group in the glucose in the carbohydrate. Oh, sorry, glucose. Okay, that was. So it's all about the carbohydrate. We have completed. Now we will discuss about the protein, and that will be in the next class. And in that next class, I hope we will also discuss about the nucleic acids. At least about the vitamins we will discuss. Okay. So it's all for this class. Thank you, Team Educate.